All right, going on here to little Billy, taking a stroll in the park when he's supposed to be doing his homework. But we'll see what's going on with little Billy right here. So, a man who happens to be named Billy is 5 feet tall. Here he is. Short little guy. We can call him Zacchaeus. A man 5 feet tall walks at a rate of 3 feet per second away from the lights. And that is above, and that's 16 feet above the ground. And we're going to see our figure right here, cool beans. When he's 12 feet away from the base, find the following. All right, well, let's go ahead and make sense of what information is given to us, and then we can go on from there. So a man's 5 feet tall. So we know that we can go ahead and know that this dude right here, we're going to say is 5 feet tall, right? 5 feet. All right. And he walks at a rate of 3 feet per second. So let's just call this our y as it indicated, and this is our x. So it at a rate of dx dy, dx dt, it as he's walking at a rate of 3 feet per second. Okay, that's how it's changing there. And this whole entire from the bottom to the top of the light is 16 feet there. When he's 12 feet from the base of the light, find the following. Okay, so what's the rate of the tip of the shadow moving? I mean, how fast is this shadow moving right here? Well, let's think about this. Do we know what the whole length is? Well, we don't. We kind of know what this is, right? This is 12, but we don't want to use 12 right here yet because we want to do this arbitrarily right now. So let's just call this whole thing right here, from here to here, I'm going to call that y, okay? And then I'm going to call from the tip of the light to where he's positioned, I'm going to call that x. And as you can see, I have a big triangle, and I have a small triangle. I can go ahead now and set up a proportion triangle right now. I could do the height of my triangle, 16, of the big one, divided by the height of the small one, 5. That's equal to the length of the big triangle, which is y, and the length of this one, which is going to be actually y minus x, right? If I take the whole length of y and I minus x, that's going to give me this guy right here. Now, the reason why I'm doing this is because the way that we do all these kind of problems with our dy dt is we need to find some kind of relationship that tells us about what we're trying to find. So say we're trying to find as his shadow is, traveling along. Well, if I was able to create a proportion that shows what's happening as his motion is traveling away from the light. So if I solve for y, 5y equals 16y minus 16x. If I add 16x to that side over there. So if I add 16x, so I get 21. Oh, no, wait a minute. I want to solve for y. I'm sorry here. I want to solve for y. Try that again. Okay, so we have 5y equals that. So if I minus 16y minus 16y, okay, and then if I divide right there, I'm going to get 16 right here. Okay, I'm going to get 16 over 11x. Okay, and this is powerful. So this is telling us that the rate of which this whole thing is moving at is 16 over 11 times x. We need to find the rate at which the tip is moving, right? Wouldn't that be dy dx? How fast is this guy moving right here, the whole thing? So dy. So if I want to find dy, I'm sorry, not dy dx, dy dt. So dy dt. Let's find the derivative of this with respect to time. The derivative of this is just 16 over 11, but you have to tack on a dx dt. And we set up here that dx dt is 3. So just plug in 3. So we get 16 over 11 times 3 right there. So that means we're going to get 48 over 11. And I guess, let's see, he's traveling feet per second. All right, so that's what he's going to travel at. So at feet per second. Okay. Now it says find the length of the shadow is changing. Okay, and if you want to find, if you want to find out what the length of the shadow is, isn't the length of the shadow just, isn't the length of the shadow, I'm just going to be y minus x, right? I take the value of y and I subtract x, and that's going to give me the length of the shadow. So really, I want to find, how is this changing? dy minus x over dt. That's what I'm trying to find right there. Okay. Well, that's the same thing as saying dy dt minus dx dt. So notice here, I'm just taking the derivative of each one separately. We just found out what dy dt is. Dy dt is 48 over 11. And it was given to us that dx dt was 3. So that means it's going to be traveling at a rate of 15 over 11 feet per second. And it's kind of interesting. So if we look right here, the guy is moving faster than the shadow. And I guess this would have been a cool little assignment outside, like you're walking, you look at your shadow like, I wonder, does a shadow really travel slower? And you can't do that. If you actually walk away from a shadow, if you walk away from a light, you notice that your shadow becomes longer and longer. And as it's getting longer, your shadow will then travel slower. So it's kind of a cool thing right there to think about. And that concludes our test corrections after an hour or so. All right, that's it.